Okay. So in the previous class, just we have a discussion about data structure and types. So continuation of that particular same concept. So in this, we are going to be discuss again what are the linear as well as non-linear, followed by each and every type of linear data structure as well as non-linear data structure. Let us have a structure of each and every data structure. Okay, so the first one is linear. Already we have a discussion in the previous session saying that definition of linear data structure is arranging a particular items in a sequential manner. Okay, that is a linear data structure. And as a part of this particular linear data structure, what were the major data structure concepts are there? First one is arrays. Next one is linear list or linked list. And coming to the third one is stacks and queues. These are the following linear data structures we are supposed to be discussed. Okay. And what do you mean by non-linear? Non-linear already we have discussed, saying that representation of data items in hierarchical or ordered manner is called non-linear data structure. Okay. So in this case, what are the various types of data structures are trees, graphs, sets, hash tables, and so on. Different concepts are included in this case. As a part of that, we are going to be discuss what do you mean by tree and what do you mean by graph and types of the trees and representation of each and every tree also we are going to be discuss with an example. Okay, so this is the trees concept and graphs and sets and so on. After these particular types of data structures, we are also going to be discuss what are the sorting techniques, what are the searching techniques. So that is also we are going to be discuss as a part of these data structures. Okay. So now let us have a discussion about first type of linear data structure is arrays. Okay. So now we will see some little bit introduction of an array followed by one or two examples we will see regarding this particular arrays. Okay. So now, in this case, generally, let me go for the first concept, that is arrays. Okay. So in this arrays, so generally, what do you mean by array? Collection of items which are similar type. But how can we define a perfect definition of an array is nothing but it is an indexed collection of fixed number of homogeneous or similar data items. And once if you are defining an array, the size of array is fixed, and also whatever the elements you are going to be adding or inserting into the array, all the elements must be same type. Okay, so that is we are going to be see that. And already in C programming we already seen what exactly the arrays concept. Again, that arrays also we are going to be discussed as a part of linear data structure. So in this case we will see some little bit introduction part of arrays followed by linear list or linked list, and how can we implement stacks using arrays as well as list, and also how can we implement queues concept or queues data structure using arrays and linked list. That is also we are going to be discussed with an example. Okay, so now let us go for arrays concept. Okay, right. So in this case, now the first concept we are going to be discussed is, okay, yeah, first one we are going to be discuss arrays. Okay, just now I have given a definition. Then how can we define an array? Is nothing but every concept will have some kind of syntax in programming languages. Okay, so whenever I am using C programming, the syntax of an array is going to be represented as follows. Is the syntax, if you consider array syntax is, so what it is, first one is data type. First one is the data type of an array, and next one is name, and next one is size. Okay, so this is the a simple syntax of an array. Okay, now example for an array is, okay, how can we define an array? You must represent the size while you are defining. This is one dimensional array. What is it is? It is one dimensional array. Okay, it is an a one dimensional array. The syntax of one dimensional array is as follows. Okay, so in this case, let us take the example for an array. Okay, so before going the defining data type, let me take some int. Okay, data type is AR and the size is 50 elements I have taken. Okay, this is one kind of one dimensional array example. Okay, and in this case, what about multidimensional again? Okay, so generally array is two types we can able to say, that is one dimensional first one is one dimensional array, and next one is in some ways you can say two dimensional as well as three as well as. So instead of saying two dimensional, three dimensional, let me say that multi-dimensional array, so that it will be very understandable to specify the multi-dimensional array. Either it may be two dimensional or three dimensional or n dimensional. Okay, so that's why I am saying that in this case multi-dimensional. Okay, arrays types. First one is one dimensional, next one is multi-dimensional. Okay, now coming to the syntax for this one dimensional, and next one is multi-dimensional. So whenever we are talking about multi-dimensional array, okay, whenever we are talking about the multi-dimensional array, the syntax is we can have multiple dimensions. What do you mean by dimension? It is nothing but index. It is an index. It will have a specific size, and the size represents that how many number of elements we can able to store in the memory. Okay, that is the size. And what type of memo elements? Represented by data type. What is the name of the array? This is the name. Okay, sometimes you can give the name anything. Okay, that is array1, A, B, C, some kind of name you can able to give for array. Okay, so in this case, let me give the syntax. The syntax is represented as follows. Okay, data type and array name, size 1 and size 2 and size 3, like that. Size 1, multi-dimension is nothing but you can go for any number of dimensions. Each and every dimension represent index. What is the index? It is having the size. You can give any size in size 1, size 2, size 3 and so on. Size n. Okay, this is a multi-dimensional. You mean you can take over here either two-dimensional or three-dimensional or any number of dimensions. But in a multi-dimensional, one thing we supposed to be remember that the first dimension is nothing but base index. Okay, this is a base index. Size 1, whatever I have given, this is a base index. The base index is required to specify compulsory. Okay, you have to represent compulsory the size at first. Okay, is nothing but the size 1 you must give the value. Violation is compiled error. Okay, so that's why whenever I am representing, let me take example int some a of 5, a of 3 is nothing but 5 and 3. What is the representation in this case? I am representing 5 boxes. Okay, 0, 1, 2, 3, 4. Okay, this is A of 0, 1, 2, 3, 4. Okay, this is the index. Okay, that is first dimension, and each and every dimension will have 3 boxes. Okay, this is a general representation of an multidimensional. How the multiple dimensions will be given is nothing but this is one dimensional as well as one more dimension. Okay, this is two-dimensional array. Okay, so in this case, this is compulsory. Okay, if you are unable to represent this particular base index, violation leads compile time error. Okay, so this is an optional case. Okay, this is optional. Okay, but it is compulsory. Okay, it is compulsory, we have to specify, and mandatory we have to specify. It is optional. Okay, so that's why this is a general representation of a multi-dimensional array, how we are going to be representing. In this case, what we have discussed simply, what is one dimensional and what is multi-dimensional. One dimensional means every array, it must have some specific type and followed by array name and size. Okay, and the size which represents how many number of values you are supposed to be stored. Okay, so for this example, what is the procedure for this example? Totally how many dimensions you are going to be stored in this case? 0, 1, 2 and so on. 49 dimensions. Okay, 49 dimensions you are having. Okay, so like this is nothing but totally 0 to 49. 50 values you can able to store in an array. Okay, this is a general representation of an array. Okay, one dimension as well as two dimension. In this the observation is all the values similar type. All the values must be similar type. Violation leads compile time error. Okay, and next one is here also you can specify any number of dimensions, but the thing is all the values must be again similar type. You can give any values over here. You can give in this case any values here. For example, I can give 10, 20, 30 and so on. I can give some 55 like that. You can give any values over there. Okay, but the number of values always 50. Maximum you can store 50. Okay, and all the values must be integer values. Okay, all the values must be integer values. This is a general representation of one dimension as well as multi-dimensional array. In this case, you can also represent how these particular values are going to be stored. Is nothing but this dimension is having how many blocks? 3 blocks you are having, and here 3 blocks. Totally how many values I can able to store in this case? 15 values I can able to store in this case. Is nothing but 5 into 3. 15 values I can able to store in this multi-dimensional array. But in this case, what is compulsory? First dimension always you have to represent. Compulsory you have to represent. Mandatory field. Okay, followed by these all are optional. You can give it runtime also. Okay, and the values I can represent like this. I have given 10, 20, 30 now. You can able to give these values again as static as well as dynamic. What do you mean by static? You can give the values for each and every index in the program itself. That is static representation. And what do you mean by dynamic? Already we have discussed. Dynamic, which means you are going to be prompting the user at runtime for storing the values in array index. Okay, so that is the dynamic. Okay.